Hi, this is correspondence analysis, and correspondence analysis visualizes the frequency dependency. And it displays the categorical variables in a property space which maps their association in two or more dimensions. And in marketing study, the correspondence mapping or perceptual mapping or social space analysis, etc., all other beautiful names are also alternatively used to indicate the correspondence analysis. So like the chi-square test, if the variable is measured in nominal scale, and if you want to map out the dependency of the two variables, then you can visualize the data using the correspondence analysis, which means before you make the chart using correspondence analysis technique, you should make sure whether the chi-squared test of these two variables are statistically significant, which means meaningful association between two variables. And the variables should have been nominally measured. So the frequency data should be the base for this chi-square test. And then if it is statistically significant, then you can consider applying the correspondence analysis for visualization. Okay, it's very simple. And yeah, if you use the R, then you can draw simply like this, and you can make a bit more beautiful like this. And let me demonstrate you how you can draw this similar chart using SPSS. And you can access to this Starbucks screen here. Let me find Starbucks screen. Starbucks row. Here, age and employment. Age has 3 levels, I think, and employment has also 3 levels here. Right, actually 4 levels. Yeah, anyway, the levels should be more than 2. If the level has only 2 levels, then it's not applicable for correspondence analysis. So you should make sure 2 things, whether both variables have more than 2 levels, like 6 colors or 4 colors or 4 packages or 3 packages, or like this different age ranges more than 2, and whether these age distinction and employment categories are statistically significant from the chi-square test, which means like younger people are usually student, and when the self-employed, which means 사장님, self-employed, then they are more like 40 or above. Yeah, there are some very young, successful men here, but successful women here, but it's a rare case. Mostly the self-employed people are 40 or above. Not really. Okay. So you should perform the chi-square test, whether there is a dependency between age variable and employment variable. And I did, and it was statistically significant, so I could proceed more for testing these data out using correspondence analysis. And now let me demonstrate you how you can create this using SPSS. So let me start my SPSS. It's not very user-friendly. When I was a PhD student, the SPSS didn't have undo. So I had to save every time whatever I made some changes. But now we have undo, and we can create multiple windows. Still recently, it didn't allow us to have multiple data set windows. So it became much more friendly, but still, yes. But anyway, it's optimized for statistical studies. Okay, so let me copy the data from here to here. Okay, and I delete this because it's not the data. And then in data view, the data are copied like this, and in variable view, variable 1 and 2. 1 should be age, so I edit this, and this is employment. Okay, right. So this is situation, and I need to transform that into the numbers. So let me transform record into let's say different variables, and then instead of age, I create age 2, and from 20 to 29 should be 20s, and 40 and above is 40. In SPSS, usually you should click add, otherwise it disappears. And then there should be like from 30 to 39, value 30. Is that all? Okay. Okay, age 2 is executed like this. All right, and then we do the same thing for employment. So here you are. The employment has been recoded. Students 1 and employed 2 and self-employed 3. I made this, and then if we go to variable view, then when the data are numbered, then automatically numeric is assigned. Here, well, actually that's nominal, right? Because we treat this nominal, or in this case ordinal. Yes, ordinal, and it's nominal, but that really doesn't affect the results because it already the SPSS is well aware of the type of the variable. Okay, so it's changed to ordinal, and this is nominal. And then analyze dimension reduction, because we will deploy these levels onto two-dimensional space, so we are reducing the dimension. Okay, so as row, column, well, this can be replaceable. So 2 variables, and then I defined between 20 to 40. By doing so, I unintentionally received 21, 22, something like that, but doesn't matter because there's no 21 data here. So anyway, the results will be the same. Plots, okay. Usually I don't think we have something to change here. Model, chi-square. Well, chi-square or Euclidean, well, it results slightly different graphics, but each has its own region. So you can try out 2 different ways. So by default, it's chi-square. So let's continue, and then here. So yeah, we only had a 20, 30, 40, right? And then 1 is students, 2 employed, 3 self-employed. Okay, so the frequency data is like this, and then row and column plots, and here 1 to 3 was student and employed 2, and 3 self-employed. So there is a tendency that bigger numbers of self-employed is closer to 40 or above, and the number one, which was students is close to 20. I intentionally recoded 20, 30, 40 to have a distinction from this red 1 to 3. So to make this chart more beautiful, let me go back to the data, and instead of 1 to 3 here, regarding the age, I can leave like this. It's very clear. So here, if I change the values to students, 2 for employed, and 3 self-employed. Okay. And I do the same thing, correspondence analysis. Okay, here you go. So previously it was 1, 2, 3, and now these numbers are replaced with students employed and self-employed. So in this way, you can draw the relationship between the categorical variables, and by double-clicking this one, you can decorate the items manually. Yeah, something like this. So you can make a beautiful chart. Or you can use R or Python for drawing the correspondence analysis. So we can do this in R. We open the correspondence analysis and we run these libraries, and we bring this Google spreadsheet, the Starbucks row, and then we do this analysis. So we take the age and employment columns, and then we do the chi-square test, so it's statistically significant. And then results, and then plot. So here 3 occupations and the age ranges. Well, I have relabeled in SPSS manually, so maybe there was one more age range which I missed, but this R is not missing such details, so you can easily draw the chart using R. Of course, you can decorate this chart by adding more ggplot functions, but by simply typing a couple of lines, you can draw the chart.